example 7.7, but we're just going to look at part C. Parts A and B are very similar to the question we just completed. Part C is a little different. A distribution of IQ scores is normally distributed, so it means it can be represented by the bell curve, with a mean of 100 and a standard deviation of 15. Find the proportion of IQ scores that are, part C is less than 70 or greater than 145. Okay, so if the question had said between 70 and 145, you would be finding the area between these two raw scores. But it says less than 70 or greater than 145, so we're going to look at something that's a little different. The mean and the standard deviation, we have 100 for the mean, which places it in the very center of the bell curve, and right below it we'll also label a standard deviation of 15. 70 is on the left side of 100 and 145 is on the right side of 100. Scores that are less than 70 represent this proportion of area, everything that goes from 70 down to negative infinity. Scores that are greater than 145 is this proportion of area, so it goes from 145 all the way to positive infinity. If we are being asked to find the proportion of IQ scores that are less than 70 or greater than 145, we're being asked for the sum of the area of this shaded tail on the left plus this shaded tail on the right. That's what the OR means in this particular question. So we're going to find the area to the left of 70 and we're going to find the area to the right of 145, and then we'll add them up. So to find the area to the left of 70, we're going to go to our calculator and we're going to put in a negative 100,000 for the lower z-score. I meant to say lower raw score, negative 100,000. We're going to enter 70 for the upper raw score. The mean of this question was 100. Actually, I forgot. The mean is 100, the standard deviation is 15. Okay, so we have our low raw score of negative 100,000, which is essentially negative infinity, up to 70, with a mean of 100, standard deviation of 15. This will give us the area in the left tail. So we take it, and instead of rounding at this point, we're going to take this as many digits as we see on our screen, because this is going to be added to the area on the right tail, which we don't want to round until we get to the very last step. So let's take down 0.022750062. Okay, so 0.022750062. Now to find the area on the right hand side, we're going to find the area to the right of 145. So we go to our calculator, we go through the same process, NormalCDF, but our lower is not negative infinity, it's 145. Our upper is positive infinity because this area is reaching all the way towards the right. We're going to leave our mean and standard deviation as it was and paste. And we're going to take down this number, 0.00134,99672. So to find the area that's either less than 70 or more than 145, we're going to take this proportion of area plus this proportion of area. And then we'll round our final answer to 4 decimal places. Okay, so Adding them two together, we are adding 0.022750062 plus 0.0013499,672. We'll add them together and round our final answer to 4 places, which is 0.0241. Now again, we should never be arriving at a proportion of area that's greater than 100. Or negative or something like that. We're always looking at a number between 0 and 1. So this proportion of area, 0.0241, makes sense. It's 2.41% of the bell curve. Okay, let's try example 7.8. I'd like you to maybe try this on your own. And so pause the video after I start explaining this. Pause the video and then come back and we'll go over it together. 1,000 students took a standardized psychology exam. The results were approximately normal with a mean of 83 and a standard deviation of 8. So if the results of the standardized exam were approximately normal, it means that we can draw a bell curve to represent the results. In the center of the bell curve, we'll have a mean of 83 and a standard deviation of 8. This question is a little different because it doesn't ask you to find the proportion of students. It asks you to find the number of students who scored less than 67, greater than 87, and okay, those 2 parts. Less than 67 and part B greater than 67. So you're not finding the proportion of students, which basically converts to a percent when you multiply by 100. You're being asked for the number of students. Now, how are you going to find that? Well, you're told that 1,000 students took the exam. So if you're told that there's a total of 1,000, you can figure out how many particular students based on the percent of students that scored less than 67. So if you can find the percent of students that scored less than 67, then you could easily find out how many of them we're talking about if we know we're starting with a total of 1,000. Okay, so pause the video and see if you could come up with some answers for this. To find the answer for the number of students who scored less than 67, we first start with a picture. Since the results are based on a normal distribution, we make our bell curve, and in the very center we label the mean 83 and our standard deviation 8. 67 is a raw score on the left side of 83. So we're going to label 67 on the horizontal axis, and we're going to shade all the area to the left of 67. This is the proportion of area of students who scored less than 67. That's not the number of students, that's the proportion of students. So we have to recognize the difference. We start by finding the proportion of students. So we're going to go to our calculator's NormalCDF function. We're going to enter a lower value of negative 100,000 for negative infinity, an upper value of 67, a mean of 83, and a standard deviation of 8. And when you put that into your calculator's NormalCDF function, you get the proportion of area, 0.022750062. That's the proportion of students who scored less than 67. That's not the number of students, that's the proportion of students. So at that point, how do you figure out how many students scored less than 67 when you know the total number of students is 1,000? Well, the easiest way is to basically take this answer in your calculator and just multiply it by the total number of students. Multiply it by 1,000. Okay, so let's go to our calculator. I'll show you how to do it. So I'm going to recap how we get the proportion. The lower is negative 100,000. The upper is 67. The mean 83. 83 and the standard deviation is 8. Okay, we're going to paste and get an answer on the screen which represents a proportion. So, to find out how many students, we simply take that proportion and multiply it by the total number of students. Some of you may like to do cross multiplication. Maybe you'd like to set up a fraction, an equivalent proportion, and then do cross multiplication to solve for x or something like that. But the easiest way for you to do this is simply to take the proportion and multiply it by the total. So if you just press multiply by 1000 after you get your answer for the proportion, you'll arrive at the number of students. Now, since we're talking about students here, it's not going to make sense to leave it as a decimal. So I'm going to ask you to round to normal, using normal rounding rules, and round to the nearest whole number. So this becomes 23 students. Rounding to the nearest whole number becomes 23 students. Okay, so we'll multiply 1000 times the proportion, and that will give us 23 students. Greater than 87, similar process. This time we're going to go into our calculator and put in 87 for the lower value, 100,000 for the upper value, 83 for the mean, and 8 for the standard deviation. And we get a value of 0.3085375322. That is a proportion of area, not a number of students. To find the number of students, we're going to simply take this proportion and multiply by the total number of students. So we're going to take 1000 and multiply by the proportion that we got on our calculator. And after we get a number, we're going to round to the nearest whole number for the number of students. 308.5, which makes us round up to 309 students. Okay, round to the nearest whole number. So we have 309 students scoring more than 87, and we had 23 students scoring less than 67, I think. Was that it? Yes, 23 students scoring less than 67.